Hey.
Sorry. I'm Ollie, this is Cliff, and for our final design project, we built a thermostat. Basically, our system requirements is we have a temperature sensor from which we can have continuous temperature readings, or we can just have one temperature being read at a single time. The temperature is then displayed on an LCD screen, and we can change the units, so we can have it displayed in Celsius, Kelvin, and Fahrenheit. Our next board also outputs a square wave at 3.3 volts peak at 1 kilohertz, which is then used to control a fan using pulse modulation. So hardware architecture is pretty similar to our previous labs, except we use a temperature sensor. It's a PMOD from Vigilant. It's a we could either use a SPR or a GPIO. So we just decided to use it as a GPIO. We also output the function at the square wave straight from the timer counter. We did not use the DAC. And we built a small switch in between. We built like a pretty simple PNP BJT switch for our pulse modulation. The load is our fan, which is a linear load.
Our software architecture. This is how our PMOD reads temperatures. So first you need to write to the configuration register, and so you check the resolution for either it does 9, 10, or 12, 9, 10, 11, 12 bits. That's for like decimal places. So ours right now is 12 bits. And then you want to start temperature conversion, which converts what you're in the temperature register. And then there's in the configuration register, I think the 7, the very last bit, it checks if it's done. So you always want to check if it's still converting the temperature or not. And then if it's done, then you can read the temperature and then store it. Or if it's not done, then you just keep reading the configuration register. So for our hardware, we've got a Vigilant sensor we got a temperature sensor from Vigilant, reads temperatures. We made a BJT PNP switch, which handles, because at first we wanted to hook up the fans just straight to the timer counter, but it was drawing too much current, so we had to make a switch to handle that current. And then we have our loads, our fan. And then for the software, we use pulse width modulation. Our first approach was to use the function generator from experiment 4, but that kind of fell through because we used the interrupt, and it did funny things when interrupt was trying to also and the conversion when the temperature was trying to convert also. So we just made it use the timer counter, and then we wrote the interface for the temperature sensor.
Basically all of our hardware and software are tested and ready to go. So we can just demo it right now. Yeah.
Alright.
So we set our temperature threshold for the fan to turn on at 29 degrees. So you're going to use a heat gun.
This is all Celsius.
Yeah, this is we're Celsius right now, so you're going to use a heat gun to heat up the wires. It just takes the voltage differential and then converts it using a sensor. So hopefully this works. I don't want to burn my phone.
That's like 20 degrees Celsius, then 29. Fan speeds up to at full speed, and then as it drops, the fan starts slowing down.
And then we can like, and the fan actually like slows down, so as it speeds up, and we can with the switch we can control whether we want at what temperature. So if right now the switch is on, so it's not gonna record anything until we turn up the switch again. So can you turn up the switch? It's gonna record it, and it'll speed up the fan accordingly. And we can switch the using a button, we can just switch the units from Celsius to Fahrenheit to Kelvin.
Nice.
And that's all it is to it. We wanted to like switch, like have the temperature change the fan, but we just could not find a bigger fan to make a big impact. So you could see like as the temperature went up, the fan would jump in, and it would be a big enough fan so that it would just change the environment temperature drastically for it to fall. But we just could not find a fan big enough, and that the board could not handle anything like that. But right now it's just because room temperature is about 25 degrees Celsius. It's pretty accurate. It's very accurate. That's all.
Do you have an idea of what the accuracy really is?
We use a thermometer, and it's actually pretty accurate. And
1%?
it's about I did the air was about 3%. So, yeah. But yeah, that's all there is to it.
Yeah!